Let's jump straight into this explainer. Imagine stepping outside tonight. You look up, totally expecting to see the familiar glow of the moon hanging there in the sky. But it's just gone. I mean, no explosion, no warning sirens, no mysterious flash of light. Just erased. Literally 1 second it was there, and the next, absolutely nothing.
So what if it really did just vanish? Honestly, at first, half the planet wouldn't even notice because it's daytime for them. And millions more live under city lights so bright they barely even look at the stars anyway. But give it a few hours and social media would absolutely erupt. People asking, "Where's the moon?" Astronomers globally would scramble to their telescopes, furiously checking satellite data, only to confirm the unthinkable. Our celestial companion vanished without a trace. It didn't hide behind Earth, it didn't drift away, and it definitely didn't shatter. It's just gone.
Now, the moon isn't just some pretty rock in the night sky. For over 4 billion years, it has been one of the most absolutely crucial stabilizing forces our planet has ever had. So losing it, that doesn't just mean a darker night. It triggers an immediate, invisible chain reaction across the entire globe that would fundamentally reshape everything we know. To really grasp the scale here, we're going to track this escalation of disaster. We'll start with the first 24 hours, move into the first months, see what happens centuries later, and finally, look millennia ahead. Okay, so here's the crucial point about tides. Every single day, billions of tons of water are constantly moving in this massive gravitational dance. And yeah, while the sun does exert its own pull, the moon actually does the heavy lifting. It's responsible for about 2/3 of our tidal strength. So without it, we'd wake up to coastlines with unusually calm seas, and our high tides would shrink dramatically. But the real danger, that's happening way beneath the surface. It's like an invisible engine in the deep ocean suddenly stalls out. You see, tides don't just slosh water around, they mix the oceans. They transport vital nutrients from the cold deep sea right up to the surface. And that feeds microscopic plankton, which, get this, produce roughly half of the oxygen we breathe. Without that strong tidal mixing, all those essential nutrients just get trapped in the dark abyss of the deep ocean, which leads straight to the collapse of marine ecosystems. Think of it like shutting off the fertilizer to Earth's biggest farm. First, you get stalled tides, which lead to trapped nutrients. That causes a massive plankton decline and ultimately total fishery collapse. The fish that rely on these currents just can't find food. Season by season, entire fisheries die out, leaving communities that depended on the sea for generations facing a truly terrifying, uncertain future. And it's not just the oceans taking a hit. Up on land, ecosystems suddenly lose their oldest clock. The chaos is wild. Coral reefs, which actually time their massive spawning events to moonlight, failed to synchronize, so reproduction just plummets. Sea turtles wander totally aimlessly on beaches, unsure when to nest. And in the sudden, pitch-black nights, nocturnal predators, owls, wolves, big cats, lose their greatest hunting advantage. The whole food chain is thrown completely out of rhythm. Nature would literally have to adapt overnight. But actually, scratch that. The most terrifying atmospheric changes begin with something we can't even see: Earth's axis. You know, that invisible line running straight through the North and South poles. For millions of years, the moon has acted like this giant, cosmic, stabilizing weight, quietly holding our axis steady and keeping the planet perfectly balanced. Today, our planet is tilted by exactly 23.5 degrees. That specific number is basically everything to us. That 23.5-degree tilt is what gives us our gentle, predictable seasons: spring, summer, autumn, winter. It's the absolute foundation of the climate stability that allowed human civilization to flourish in the first place. Take away the moon's massive gravitational weight, and Earth just begins to wobble. At first, it's tiny. Nobody would notice it tomorrow. But run the computer simulations, and the future is frightening. Without the moon, our tilt could eventually swing wildly over thousands or millions of years. Just picture tropical rainforests suddenly buried under snow, or massive deserts turning into wetlands. Polar ice could melt entirely in one era, only to creep all the way down to the continents in the next. Eventually, we are left with exactly this: a world out of balance. Surviving this shift becomes a literal geographic lottery, and humanity has to actively reshape its environment. As climate zones migrate globally and historic coastlines freeze over, we'd see massive human migrations, entire cities forced to relocate. To not starve, we'd have to build gigantic indoor AI-powered farms. And to save the dying oceans, scientists would have to construct massive artificial tidal pumps to forcefully recreate the mixing the moon used to do for free.
Culturally, the shift is just as mind-blowing. Fast forward enough generations, and the moon is just a myth to them, a story like Atlantis. But without all that moonlight washing out the sky, astronomy enters a true golden age. The Milky Way would stretch so vividly across the heavens every single night. Kids would grow up recognizing thousands of stars instead of one bright moon. So deep space observatories start realizing that Earth-like planets without moons have insanely unstable climates. We'd make the startling realization that a large moon might actually be the hidden reason intelligent life developed here at all. And that sparks our greatest, most desperate engineering challenge. Can we replace the moon? If nature won't protect Earth anymore, can we build a new one? Well, the biggest obstacle is simply unimaginable mass. Gravity does not care what you build something out of, it only cares how much matter is there. To recreate the gravitational pull that shaped our world, we would need an object weighing over 73 quintillion kilograms. Yeah, 73 quintillion. So what are our options? Capturing an asteroid versus building an artificial moon? We know NASA's DART mission proved we can steer an asteroid, sure, but even the biggest ones are tiny compared to the moon. It's literally like trying to replace a skyscraper with a garden shed. And building a massive artificial satellite? That would require more material than humanity has mined in its entire history combined. The scale is just off the charts. That's why some scientists suggest an entirely different route: stabilizing Earth itself. We're talking planetary engineering, gigantic orbital engines, or fleets of massive satellites using gravity to counteract Earth's wobble. For the first time ever, the greatest minds on the planet would unite behind one single goal. Not for conquest, not for exploration, but purely for the survival of our home. But even if we pull off that technological miracle, no machine can replace the cultural legacy we lost. Because the moon was never just Earth's satellite, it was Earth's partner. It watched the rise of kingdoms, the very first campfires, the invention of the telescope. It's a reminder that we exist because for billions of years, Earth was never alone in this ancient cosmic dance. So, I'm going to leave you with this final provocative thought to ponder in the comments, straight from our source material. Which scenario do you think would be more terrifying for humanity? Losing the moon forever and facing this slow, creeping planetary chaos? Or losing the sun for just 24 hours? Let us know what you think. Keep looking up because the universe is packed with questions and every single answer just leads to another awesome mystery.